Hello everyone, and welcome to the second video in this video series about the review for the AP Statistics exam. In this video, we're going to talk specifically about the four types of graphs for quantitative data. In the previous video, we kind of introduced the fact that they exist, but didn't talk about the specifics or how to actually make one. So I wanted to take the time in this particular video to talk about how to make one, when it's appropriate, when you may have to do it. And then in the following video, we'll actually talk about how do you describe each type of picture. So the four types of graphs, just as a quick review that we talked about, was a histogram, a box plot, a stem plot, and a dot plot. And now three of these are very similar. A histogram, a stem plot, and a dot plot are very similar and give you very similar information. A box plot is the one that is slightly different. And so my plan for this video is to go through what each one looks like, how do you physically create one yourself, and then additionally, what are some advantages and what are some disadvantages to each type of picture. And so up first, we have the histogram, which this is just, again, something I pulled off of Google Images as an example of a histogram. But the big things with histograms, like we talked about in the previous video, is that your x-axis is quantitative, right? It is your variable. And your y-axis represents frequency. It's one of the biggest things. The y-axis represents the frequency within each interval. Now, in order to actually make a histogram, one, you can do it on your TI calculator, and that's something I will probably cover in a separate video as well, just to show you specifically how to do that when I have access to a TI emulator. But if you were going to do this by hand, right, let's say they gave you a frequency table and they asked you to do this by hand. Very simply, the first thing you want to do is create your intervals, and we call those bins. So we're going to have 5 to 8 intervals or bins. And the reason or the reasoning behind 5 to 8 is that if you only have 2 or 3, you can't really tell much about the picture. And if you have too many, you have 20, 25, every interval is only going to have one data point in it. And so you're not actually gaining any information about what this data set looks like. It's just a repeat of the data set itself. One thing that's very important here is when you create your intervals, you want no overlap. No overlap in your intervals. You can't have 1 to 10 and then 10 to 20. The reason for that is if you have a data point that is 10, you don't know which interval it will go to. So typically the way you'll see this written is that it goes from 1 to less than 10, and then the next interval will include that endpoint. So 1 to 9.999 forever, and then 10 to 19.999 forever. Once you establish these, we got to find our bin width by just doing the range divided by the number of bins. And again, the important reason, I mean, that's just simple math, but the other important thing about this is that you want to round that to the nicest number you can. And if you get 8.75, I would probably just use 10 as your width. It's not an exact science when you create the width of these things. The goal is to make it as easy as you can for yourself. If you get a wacky width, again, like even 7.32, I'm probably not going to round to 8. I'm probably still going to go to 10. But again, it depends on the scenario. And then afterwards, all you have to do is count the frequency in each interval. So the last thing left to do is to count your frequency. And then that's going to represent your y-axis, and your x-axis is your bins or your intervals. And so that is the very basics of how you can create a histogram by hand. Now, like I said, I will probably have a separate video where we talk about how to create a histogram using technology, because you'll have access to your calculator on the exam. I just don't have access to a TI emulator right now to be able to show you the best way to do that. So, some of the advantages of histograms. One of the biggest advantages is that you can see the shape of the data. You can see what it looks like very quickly. You can also quickly see the center. And by center, I mean the median of the data. Right? So very quickly, you can pick out two very important pieces of information, being what is the shape of it? Is it approximately normal? Is it skewed left? Is it skewed right? Is it bimodal? Is it et cetera, et cetera, et cetera? And you can also roughly figure out where the median is. The disadvantages, because there are a few as well, is that you lose all the data. Now, what I mean by that is that I don't know any one individual data point. If I just hand you a histogram, you may know that there's 5 data points between 5 and 10, but you have no clue what those numbers are. You don't know if they're all really close to 5. You don't know if they're all really close to 10. You don't know if they're somewhat spread out in between. You just don't know. And the other thing is, we have no idea about outliers. So in this particular case, you can have a potential outlier or a possible outlier, but you won't know for sure. Because you don't have the data, there is no way to calculate whether or not something is an outlier. So you can surmise or try to, make a guess about, I think this data point is a potential outlier, but there is no concrete answer to that question. So, moving on. Box plots are created using your 5-number summary. And that 5-number summary is your minimum, your first quartile, your median, your third quartile, and your maximum. Now, the minimum, the median, and the maximum are exactly what they sound like. Remember that your first quartile here is just the median of the first half, and your third quartile is the median of the second half. What's important in calculating that is that the median is not included in those calculations. Not really a calculation, but in that counting. So if you have an odd number of data points, that median gets crossed out and is not used in your calculation of the first and third quartile. And now again, this is something that your TI calculator will give you. And sometimes on the AP exam, they will just straight up give you the 5-number summary and ask you to make a box plot. But they may ask you to calculate it. They may ask you to do a bunch of different things. And that's what we're here to talk about. So here's an example of a box plot. This is pretty easy. This is your minimum. Over here is your maximum. Your median is here in the middle. And then your first quartile and your third quartile make up the other ends of the box in the box plot. And so it is that simple, where the quartiles, because sometimes the median is called the second quartile, your quartiles make up the box, and we draw lines, sometimes called whiskers, to the minimum and the maximum. So the other name sometimes you'll see for a box plot is a box and whisker plot. Now, a box plot is great. As you can see, it's very easy to make. but it also has some disadvantages. So let's talk about those here. Your advantages here, easy to make, right? Very simple. All you need is 5 numbers and you draw a picture. The other advantage is that we have outlier fences. So now I know if I have outliers or not. Unlike with histograms, we don't, where we didn't know outliers, now I will know for sure. So if I have a value that's less than the first quartile minus 1.5 the IQR, or if I have a data point that's greater than the third quartile plus 1.5 the IQR. Remember, you can be on the fence, right? I said this multiple times. The line is in. Think of it like tennis, like volleyball, like baseball. The line is in. That is important. It's not like basketball where the line is out. The line is in. Now, will you have a point on the exam that sits exactly on the fence? Highly unlikely. I have not seen that in any released exam ever. I haven't seen it in any singular question of the 1,294 that are on AP Classroom. But just as a reassurance. The disadvantages here right? Because we gained the information about outliers, we lose the information on shape, right? So all we can talk about now is symmetry. We don't know because here's the thing, an approximately normal histogram and a uniform histogram could produce the same box plot. Any box or any histogram that is symmetric, whether it's bimodal, normal, uniform, insert any symmetric looking histogram, will have a symmetric box plot. And so just because your box plot is symmetric doesn't make it approximately normal. And just because it's asymmetric, I really don't know what that looks like either, because similarly to a histogram, I only have 5 data points here. I don't have any other information. Now, the other 2 types of data displays, I'm going to go through relatively quickly. A stem plot is essentially a histogram, right? This is essentially a histogram. You have an example here on the right-hand side. And for this particular example, the width of each interval is 10. One thing I will highlight that's very, very important here is that you need to have a key when you make a stem plot. So that way people can read it. So typically the stems are the tens place, and then the leaves, this is sometimes called a stem and leaf plot, are the ones place. So you can see here the 1 vertical line 7 means 17. The thing is, if you take a stem and leaf plot and turn it 90 degrees, you have a histogram. And so when we look at our advantages and disadvantages, one of the advantages is now we still have the data along with the shape. So with a histogram, I lost the data, right? I just knew that there was a certain amount between 2 data points. Now I have the data and I have the shape, which is great. One of the disadvantages, though, is just it's annoying to make. And in reality, if you're trying to determine outliers or something along those lines, a box plot is probably a better option. And you can't do this on your calculator. So a stem plot, while it is helpful, probably isn't something that the AP exam is going to ask you to make, but they may ask you to interpret it and use it for something. So I haven't seen them make you make a stem and leaf plot, but I have seen them ask for an interpretation of one. The last data display is a dot plot. which is essentially a histogram. Again, this is essentially a histogram again. Each dot on a dot plot represents one data point. So this is a histogram with a width equal to 1. And so you can see here, this is, again, just a picture I pulled from Google Images. Looks just like a histogram. We have a width of 1. Great, right? So I have the whole data set again. When we look at the advantages, it's going to be the same as a stem plot. Right? I can see the shape and I have all the data, which is great. The biggest disadvantage is that the picture is busy. You could imagine if you had this picture here, how incredibly busy that might look if I had 100, 200, 300 data points. It would just look like someone threw paint at the wall. And so dot plots can be great if your data set is a little bit smaller. However, if you end up with a lot of data, a histogram or a box plot is most definitely going to be your better option here. So in our next video, we're going to talk about how do we actually describe each of these shapes or each of these types of graphs using their shape and other things. But for now, I hope that this was a good overview for you on just the 4 basic data displays we use, and I'll see you in the next one.